Imagine waking up to a world where computers crack problems we once called impossible, while AI plans your day before your alarm decides when to ring. Two forces racing on parallel tracks, sometimes colliding, always accelerating: quantum computing and artificial intelligence. Today's AI is already everywhere: large language models that reason across text, images, audio, and code; generative systems that turn ideas into prototypes; agents that optimize supply chains, schedule fleets, even co-design new medicines. Within the next few years, it will get personal. Clinics shifting from population averages to models tuned to your genome, cars negotiating intersections without lights, scientists running thousands of hypothesis tests overnight. Yet this power raises demands we can't ignore: fair data, auditability, alignment with human goals, regulation that protects innovation without letting it run wild. Now meet the other engine: quantum computing, machines that don't just compute zeros and ones, but explore many possibilities at once through superposition and entanglement. Early hardware is noisy, yes, but every qubit added stretches what can be simulated, and each algorithmic breakthrough widens the gap between very hard and now we can. Picture quantum chemistry models that predict the behavior of new molecules before a single beaker is lifted. Superconducting materials discovered in silico, optimization landscapes that used to trap classical algorithms, now mapped in a single sweep. Encryption gets rethought, security upgraded, and the internet's foundations rebuilt. Where these worlds collide, the sparks are brightest. Quantum-enhanced machine learning could spot patterns buried under astronomical combinations. Quantum kernels and variational circuits may become the microscopes for datasets too complex for classical eyes. Training next-gen AI on quantum-powered simulations of cells, catalysts, climate, markets compresses years of trial and error into days of exploration. And when quantum networks arrive, a quantum internet could link sensors, clocks, and computers into one secure global substrate for distributed intelligence. Still, these technologies won't replace each other. AI will keep sprinting on classical silicon, unlocking automation, design tools, co-pilots, and entirely new interfaces for how we think and work. Quantum will target the intractable: exact chemistry, brutally hard optimization, high-fidelity simulation. In some futures, AI dominates consumer life while quantum hums backstage inside labs and data centers. In others, quantum breakthroughs hand AI a new class of training data and reasoning tools, igniting a second intelligence boom. The most likely future is hybrid: AI steering experiments, quantum engines exploring possibility space, classical compute orchestrating the flow. Each system doing what it does best, all three acting as one. That hybrid future demands more than hype. It requires engineers fluent in both tensor calculus and qubits, policy that anticipates misuse, and shared standards for safety, privacy, and access, so this power isn't gated behind a few locked doors. So here's the call to action: invest in interdisciplinary teams, fund open benchmarks, teach ethics with algorithms, and prepare for jobs that blend model design with lab science. Forget the false choice between quantum and AI. The real story is synergy: tools that think, machines that explore, and people who decide what future they serve. The question isn't which technology will redefine our world. It's how we, together, will define the world they make possible.